My name is Justine, and I'm here to talk to you about environmental DNA. So for my PLE Capstone project, I interned with the CRAB team, which is part of Washington Sea Grant, and they are a citizen science community project. So the CRAB team is specifically looking for European green crab, which is an invasive species in the Puget Sound. And we should care about these species because they like important habitat that we have in Washington, such as eelgrass. And these habitat are really important for maintaining biodiversity, and they're for keystone species in the Washington area. So the CRAB team has a set of volunteers who go all along the inland shoreline and set up crab traps to find these early and prevent an invasive species outbreak in Washington. So I was interested in exploring the policy side of these implications. So my site supervisor worked with environmental DNA, which is a genetic technology that can be used to detect the presence of a species, even if it's not present physically at the site. So I wanted to see what the benefits of eDNA are and the barriers to adopting it into environmental policy, specifically to benefit current monitoring efforts of the green crab. So at my time with the CRAB team, I was an outreach intern. So I wrote up a series of blog posts specifically about eDNA and what the CRAB team did with their eDNA efforts in the program. And for my personal research, I interviewed 17 eDNA experts about social barriers. So what I got, the main benefits were that it benefited early detection and rapid response. So our ability to find these outbreaks early compared to traditional efforts with nets. It was a more sensitive method. It was cost effective. It could survey broader areas. It used less effort for the actual sampling process, and it could measure community composition, which has important implications for measuring biodiversity in these communities, especially with climate change in mind. And the barriers were misperceptions and misinterpretations of eDNA, how it works and the results, how standard protocol works with an eDNA detection, and funding for these projects. So a couple ways we can address these barriers to put it into policy: communication. So we can specifically address the issue of standard protocol by creating a standard protocol at an agency level. So it can reduce communication errors between managers and researchers if there's a standard protocol from an agency perspective. So it's not on the researcher to explain how it works to the agency. They already have a standardized response. Another way to fix this is education. So there's a lot of discussion about managers not fully understanding how eDNA works or not knowing what to do for a response. So if we have an educational program on eDNA that is provided for free to any managers, this can help them better understand how to use eDNA effectively to inform decision-making. And the CRAB team overall serves as a good case study of how we can do this and pair eDNA and standard trapping methods to more effectively assess an area for an outbreak. In conclusion, we need to combine the technologies we currently have to combat any new invasive species that are occurring. And I believe that environmental DNA is an example of a new technology we can use to improve our monitoring efforts. I'd like to thank my site supervisors, my faculty advisor, and my friends and family for all their support throughout this process.